What is Sage? Sage is a free open source mathematics software system created as an alternative to programs like Magma, Maple, Mathematica, and MATLAB. It uses a Python-based language, so if you're familiar with Python, it should be very easy to write code in Sage. If not, don't worry, in this video we'll cover all the basics of Python you need to write your simple code in Sage. You can use Sage in one of two ways. You can either download the software or use the online Sage Math Cloud. If you download Sage, you get the benefit of a command line functionality, which is useful for doing simple calculations with Sage-specific methods, like finding the inverse of 13 mod 17. So, you can also open up the notebook in a browser to write multi-line code. Here you can create a new worksheet. Code is typed into the cells and then evaluated by clicking the Evaluate button under each individual cell. So you can see that 3 plus 7 is 10. New cells are added whenever you evaluate one cell or by clicking these little plus buttons above and below the worksheets. You can delete a cell by deleting all of its contents. If you have more than one cell, you can evaluate all of them by going to Action, Evaluate All. In this version of Sage, however, you cannot evaluate more than one statement within a cell. So this will only evaluate 4 times 6 and not do anything with 3 plus 7. You can save your worksheet by clicking Save or Save and Quit up in the top right corner. And the best way to export this to a PDF would be to go to File, Print, again, File, Print, and then save it to a PDF.
If you don't want to download Sage, you can use Sage Online. You just have to create a project, and then create a Sage worksheet within that project. Make sure to click Sage Worksheet, and this will give you a blank worksheet for you to type and run code. So if I type a few lines of code, and press Run, it should work. Sage runs code in small blocks, so I can run a separate block of code under what I wrote before. And I can also run by pressing Shift-Enter. To print this code and output, or export it to a PDF, I just click on this PDF icon, click Generate PDF, and a PDF will pop up.
Sage is a Python-based language, so we're going to start out by quickly covering the basics of programming in Python for those of you who have never coded before or are unfamiliar with Python. As you're writing your code, you can make comments to help you or a reader better understand what is happening. These comments are denoted by pound signs, and anything after a pound sign will not be evaluated by the computer. First, we should talk about data types. The 5 main data types that you'll need to program in Sage are integers, floats, strings, booleans, and lists. Integers and floats are numbers. An integer is what you would expect it to be, and a float is any number with a decimal point in it. So 5 would be an integer, while 5.0 would be a float. A string is a series of characters. We denote strings by surrounding them with either double or single quotations. So these are both strings. A Boolean is a statement that evaluates to either true or false. These are spelled with capital letters. A list, as you'd expect, is a list of items, though they don't necessarily have to be of the same data type. We surround our list with square brackets and separate the values inside by commas. You can put any of these data types that we've talked about inside your list, including another list. We can perform all our normal math operations on both integers and floats, so addition, subtraction, multiplication, and division. We can also denote exponents with ***, which is the Python notation. So 3***4 is 3 to the 4th, or 3 4, which is not accepted in Python but is accepted by Sage. Some other operations that we can use in Python are // for floor division and %sign for modulo. We can also perform addition on strings. That works as you'd expect. We can add 2 strings together to get 1 longer string. Now, let's talk about variables. Variables are essentially the nouns of programming. A variable is a name that refers to a value or an object so that we can use that value or object later. For some very basic examples, you can have the variable alist refer to, say, a list of integers. Or you can have the variable meaning of life refer to the integer 42. Variable y can refer to the Boolean true. It's important to note that when naming variables, capitalization does make a difference. So meaning of life with a capital O and a capital L would be different from meaning of life in all lowercase. Once we create these variables, we can use them as we would use those specific data types. So just like we can divide 42 by 3, get 14, we can also divide meaning of life by 3 for the same result. While variables are the nouns of programming, functions are the verbs. A function is an action that can be performed. For example, if you have a block of code that performs an action that you know you're going to want to do over and over again, you can write a function to give that block of code a name. And then every time you want to do that thing, you can call the function instead of rewriting the exact same block of code. Some simple Python functions you will probably find useful are print, .append, and len. Print simply displays a string. So we can say print input our string, enter, and it will print our string. We can use the .append function to add elements to a list. Let's say we have a list here called CList that doesn't have anything in it. I want to add elements to the end of this list, say name of the list .append item. And let's print our list so we can see what is in it. Now our list contains 1 and math. Finally, we can use the length function, which looks like this, to evaluate the length of a string. I'm putting the string between the parentheses. Hello has 5 characters, so the length is 5. If we want to find the length of a large integer, we can also do that. But the length function only finds the length of strings. So first, we would have to convert to cast this integer to a string by simply saying str and then surrounding the number by parentheses. Now we can see that this integer is 20 characters long.
With programming, you don't always just want to run through every line of code one by one, so we use what we call control structures to dictate what code we want to run and how many times. Before we start using control structures, we'll need to understand conditional statements, or Boolean statements. These are just expressions that evaluate either true or false. For example, 5 is greater than 4 would return true, while 6 is less than or equal to 2 would return false. These signs in the middle are what we call Boolean operators. And the Boolean operators used in Python are greater than, less than, greater than or equal to, less than or equal to, equal to, not equal to, and we can combine these Boolean statements using and or. Make sure to notice that equals is not one equal sign, but two equal signs, and not equals is using an exclamation point. So if I give you a few examples, you can say 5 is greater than 4, and 6 is greater than or equal to 2, and this would be true. I could also say 5 is greater than 4, or 6 is less than or equal to 2, and this would also be true. These just follow simple logic. Now let's move on to the most basic control structure. This is an if statement. An if statement follows the format if, conditional statement, colon, and then some block of code. If this conditional statement within the parentheses is true, then this code will run. If it's false, it'll just skip this block of code and move on. You can also add on an else statement, which runs if the condition was false, and you can also have elif statements or else if statements that add on to other conditions. Let's look at an example. In this example, x starts as 4, and we check to see if x is less than 2, which is false, so we move on to x. Check this conditional statement where x is less than 6, and that's true, so we run this line of code, x equals x plus 2, so 4 becomes 6, and this should print 6. Beyond if statements, we also have loops, which allow you to run the same block of code multiple times. There's the while loop, which has this format, which is essentially saying, while this conditional statement is true, this code will run. So after you run it, it checks again to see if it's true, and then it runs again until this becomes false, and then it jumps out to the rest of the code. For example, x equals 0, and while x is less than 10, we're going to run this line of code. So when x is 0, x is less than 10, so then x becomes 3. 3 is still less than 10, so then x becomes 6, and 6 is less than 10, so x becomes 9, and 9 is less than 10, so then x becomes 12. And when x is 12, 12 is not less than 10, so this breaks out of this loop, and we're going to print 12. Another kind of loop we have is a for loop, which has the general format for loops are used to loop a block of code a certain number of times instead of basing it on a condition. So we're going to use some kind of counter, which you'll usually use the letter I, and that's going to start at the range A and then go up to B. So A and B are integers. So we could go from, say, 0 to 10. Actually, when we start with 0, you don't actually have to include a 0. If you just put the 10, Sage will assume you're starting from 0 and going up to 10. Note that range is exclusive, though, so it'll start at 0, but it'll go up to 9 and not 10. So if you start from 0 to 10, it'll loop this 10 times. For a more specific example, we're going to use this. We're going to start with x equals 0, and for I in range 1 to 10, so it's going to loop 9 times, we're going to go from x is going to add the value of I each time. So what will actually end up happening in this loop is that x is actually going to take the sum of all numbers from 1 to 9. So we print that. Oops. We print that. You can also use a thing called a break statement if you ever want to exit a loop before the condition becomes false or before the for loop gets to the highest part of its range. Just type the word break, and that exits the loop. Now we're going to go over how to write your own functions. Earlier you learned how to use functions already created by Python, but writing your own function allows you to create code that performs a specific task once and then reuse it again and again in different situations. Here's an example of a function that sums two numbers. We declare the function and its name with the keyword def, put the name add, and then we pass in parameters a and b, which are the two numbers we're going to take a sum of. The body of the function is also indented, like in loops. And functions usually, but don't have to, have a return value, which is just the value of some data type. Here it's an integer, which returning the sum of a and b. So we do add 2 and 5, we get 7. Now let's try to combine what we learned to write a function that takes a factorial of a number. We're going to declare the factorial function using def factorial. We're going to pass in some integer n. Like with the loops, we need to start this with a colon, and then the body is going to be indented. For factorial, we're going to start with a number n, and we're going to multiply every number that's less than n to n until we get to 1. So this sounds like something we would use a loop for. So we're going to declare x equal to n minus 1, and then we're going to say while x is greater than 0, we're going to multiply n by x. So the first time it'll be n times n minus 1, and then now we want x to decrement or decrease. So we're going to say x equals x minus 1. So the next time this code runs, x is going to be n minus 2, and then n minus 3, all the way until x becomes 1, because when it becomes 0, it's going to make the statement false, and we're going to cut out of this loop. Finally, in this function, we want this to return n, so that returns a factorial. Now if we want to test this, we can try factorial 3. This should return 6. Great. Now let's try factorial 11. Seems like it still works.
Efficiency is extremely important to consider when writing some of the code for this class. When you're doing calculations with small numbers, it may not seem to matter if your code is well written, but when dealing with 500-digit primes, or hundreds of thousands of numbers, inefficient code may never finish running. We don't have enough time in this video to talk about efficiency in detail, but here are a few quick tips to keep your code from having a runtime of like 10 years. First, avoid nested loops whenever possible. It takes long enough to loop through 100,000 numbers once. If your computer has to loop through 100,000 numbers 100,000 times, that's ridiculous. Don't do that. Second, avoid computing large exponents without using successive squaring. We'll talk about an efficient way to do this in a minute, but the program cannot store numbers large enough to do these computations. Finally, use Sage's built-in functions as often as possible, because these are usually the most efficient way to accomplish any task.
Sage has a lot of built-in functions that are really useful in various calculations in number theory. We have factor, so you can factor any number into its prime factorizations. Those like is prime, which lets you test whether a number is prime or not. You have randint, which generates a random number in between the first number, and the second number, but exclusive. So it goes from 0 to 9 in this example. Primes is a set of all prime numbers. It's an infinite set. So if you run it, it tells you it's a set of all prime numbers and doesn't end. This is really useful for loops when you're trying to test different prime numbers, and you would have to use a break statement because primes is an infinite set, so it would never stop. Divides is really useful for finding out whether something like 3 divides 9. You can also use this for some integer, so like a variable, like if you want to do x divides y. Mod takes a modular, so it works a bit like the percent sign. So 15 mod 7. And there's two different versions of pow, which is like the exponentiation function. You can either just take 2 to the 8th, or we can take 2 to the 8th mod 3. Sage also has a function for the Euler phi function, so we can find the phi function phi of 40, say. And we can also take the GCD of two numbers, say 135 and 60. XGCD will give you the extended GCD algorithm. It'll give you the Diophantine equation actually for the two numbers. So you see the GCD is 1, and then it's 181x minus 143y. CRT does the Chinese remainder theorem, and for the Chinese remainder theorem, you need to input the numbers as lists. So if you were doing x is congruent to 4 mod 3, or this I guess be 1, x is congruent to 2 mod 4, and x is congruent to 2 mod 5. You'd have to input this as a list of 1, 2, 2, and a list of 3, 4, 5. So run that. get an answer. This will give you x is congruent to 22 mod 3 times 4 times 5. They also have an inverse mod function, which gives you the inverse of 4 mod 23. You can also use LaTeX or Markdown in Sage. LaTeX is a typesetting system that you may be using to write your homeworks neatly as a PDF. Just type %md at the beginning of each line and type in your LaTeX code as you normally would, then run it. And it should work exactly the same. That's all the basics of using Sage. If you ever need more information, all of Sage's documentation and tutorials are available for free online. Go to this website for a tutorial, or this website for a full documentation of everything in Sage. Thanks for watching.